Thanks, Wendy. And then I should also introduce David Phillips is here, and he's the deputy scientist in charge at the Hawaiian Volcano Observatory. And then also Fran Coloma, who's from the National Geodetic Survey. So we'll stick around afterwards if folks have questions or want to talk story for a little bit. Yeah, Wendy mentioned that we have Volcano Awareness Month every January. So this is a big initiative that we do in partnership with Hawaii Volcanoes National Park and also the University of Hawaii at Hilo. And we do events around the island to encourage people to be aware of our volcanoes, our active volcanoes, and their associated hazards. So these are the last 4 events that we're doing as part of Volcano Awareness Month. So if you have time or interest, there's one that unfortunately we'll all miss because we're here, but it's happening at 10 a.m. in the national park. And then also on the 28th, so tomorrow here, they're going to be doing a guided hike of Pu'olokuana. And then on Tuesday at 7 p.m., there'll be an After Dark in the Park presentation on the 22 eruption of Mauna Loa. So if you are, you learned some in this talk and are more interested, definitely come to that. There's going to be a lot more details. And then lastly, a talk on the 31st at the University of Hawaii about volcanoes in American Samoa, because many people don't know that actually the Hawaiian Volcano Observatory, we monitor the volcanoes in American Samoa as well. So come to that talk if you're interested in learning more about that. So today, I will mention how we monitor Mauna Loa at the very end, but most of the talk is going to be focused on what happened in 1868 here at Mauna Loa. And as I mentioned, I'm at the Hawaiian Volcano Observatory, and our mission is to monitor Hawaii's active volcanoes and earthquakes, really with the intent of keeping the public informed as to what's happening and what hazards might impact people. We also do longer-term geologic studies to understand the range of behaviors that are possible at Hawaii's active volcanoes. And again, that's to inform us what could potentially happen in the future. So the eruption in 1868 occurred before the Hawaiian Volcano Observatory was founded, and it occurred kind of at the forefront of when, well, there were Westerners arrived in Hawaii and written documentation was happening, but it's not super detailed, and so we're having to piece together this story. But we're doing that so that we can learn what potentially could happen in the future. Wendy gave me a really nice introduction, so thank you, Wendy, but just a little bit of background about me. Yep, I grew up here in Hawaii, just outside of Hawaii Volcanoes National Park, and kind of grew up in the park and knew I wanted to be doing something for my career that was outside and on the landscape, and took a geology class at UH Hilo, kind of fell in love with that and learning about the things that I grew up around. So I moved to Alaska, got a degree there, and ended up working for the Alaska Volcano Observatory, and fortunately ended up back here in Hawaii and now work for the Hawaiian Volcano Observatory and got my dream job, so I'm very happy. So today I'll give some background about volcanoes and eruptions here in Hawaii, kind of touch on what life was like in 1868, and then my plan is to just walk us through the 1868 events through firsthand accounts, because really those give us the picture of what was happening and really paint that picture well. So I'll walk through those events and then kind of talk about what we've learned, what we can now piece together in terms of what that means for the volcano's behavior. And then at the very end, touch on our current monitoring. So out of curiosity, how many folks here are from Hawaii? Okay, and then the rest are visitors. So a little bit of background. I'm sure most of the people from here already know that we're a hotspot volcano, which means that we're in the middle of a plate. So you can see this ring of fire, it's called, and it's a ring of volcanoes around the Pacific plate. And many of those volcanoes exist because of subduction processes. So where one part of the plate is being pushed under another plate, and that drives some processes that form volcanoes. Hawaii is in the middle of the plate, and we're a hot spot, which means that we have a zone of hot material upwelling from beneath the plate, and it is forming our volcanoes. The Pacific plate, we know, is moving northwest in a very, very slow manner, about at the rate that your fingernails grow. So that, that motion of the Pacific plate moving over a stationary hotspot is what results in our island chain. And we know that the island chain is really old because it extends all the way to the Aleutians, actually. So here on the island of Hawaii, we are closest to the hotspots. So we have the active volcanoes, and our island is the biggest because we're having eruptions and our island is still being built. But the further you get from the hotspot, the more that the islands become eroded and eventually they disappear beneath the surface of the ocean and their atolls, but they do stretch all the way to the Aleutians. So we know that the hotspot is a very long-lived feature on Earth. Here you can see on the island of Hawaii the recent lava flows in red and pink. So yeah, those are the most recent lava flows, but we know that actually on Maui, so the next island, Haleakala, is also potentially still active. It last had lava flows about 400 or 500 years ago. But here on the island of Hawaii is where most of the recent volcanic activity has occurred. So Kilauea volcano, many people here are very familiar with it, and probably folks on the mainland too, because it's frequently erupting. It erupted nearly continuously from 1983 to 2018 at the Pu'uo'o vent. So that's these red lava flows on the Middle East Rift Zone. There was the large Lower East Rift Zone eruption in 2018 that was really devastating and damaged many properties. So yeah, frequently erupting, and actually over the past several years we've had 5 eruptions at the summit caldera, so this feature here. And then looking further back at the geologic history of Kilauea, we know that 90% of the volcano has been covered with lava flows in the past 1,000 years. So it's really a very active volcano. And then we have Mauna Loa, which I'll be talking about today. Mauna Loa has erupted a little less frequently over the past 50 years or so, but it's still a very active volcano. And we know, again, from the geologic history and mapping efforts, that 90% of the volcano has been covered in the past 4,000 years. I also wanted to point out Hualalai, which is another active volcano here on the island, and it last erupted in 1800 to 1801. If you flew into the airport in Kona, you're landing on those lava flows. So Hualalai is very much an active volcano as well, although we're not seeing any signs of activity right now. It's pretty quiet. So looking at kind of the impacts of these eruptions over the past century, Kilauea has been pretty destructive, and part of that is because our volcanoes have these features, summits, and then they also have these features called rift zones. So here is a rift zone, the east rift zone of Kilauea, and then the southwest rift zone, and you can see that the lava flows are coming out of those rift zones. Mauna Loa, the summit caldera is here. We have the northeast rift zone extending in this direction, and then the southwest rift zone in this direction. And rift zones are weak features in the volcano's edifice where eruptions are likely to occur. So on the island where there's infrastructure in these areas, that's where impacts have occurred. So for Kilauea, over 1,000 structures have been destroyed over the past century. And you can see that here on the Pu'uo'o flow field, there was a subdivision that was covered. And then, of course, the 2018 eruption destroyed over 700, oh, was it? No, I'm forgetting the number. What was 700? Okay, 700 homes, sorry. And there have been a few deaths associated with Kilauea, some on the flow field, and then also in 1790, there was a large explosive eruption that killed many people at the summit. Mauna Loa has been less destructive, and as you can see, not much of the flanks are developed here. So there's some development down in the southwest rift zone here in Ocean View. And then, of course, the saddle road that extends through from Hilo all the way to the other side of the island is kind of in the area that has been impacted by lava flows over the past couple hundred years. In 1880 to 1881, there was a lava flow that extended, this green one here, extended into the current day extent of Hilo. So, this is why Mauna Loa is very much a concern here on the island, why we closely monitor it, and we really want people to be aware that it's an active volcano and it has the potential to impact people. Especially now with the island, the island has grown, the population has grown quite a lot in the span of time that Mauna Loa has been relatively inactive. So this is a map that Frank Truesdale made, which we use to help communicate the hazards of Mauna Loa. And the different colors are representing different time frames that these areas could be impacted by lava flows. So in red here, this whole area has relatively steep slopes, which means that the lava flows can travel very quickly to impact areas. And time frames here are the hours or days that it took for the lava flows to reach the ocean. So the lava flows started on the rift zone. We talked about the rift zone on the last slide. That's where eruptions start. But then these steep slopes mean that these lava flows can travel very quickly to reach the ocean in as little as a few hours. So this region that we're in right now is kind of the highest concern for the island. Then there's also, in blue here and orange, these slopes are less steep, and this area is relatively undeveloped. So it would take some time for lava flows to impact an area, and that is what happened last year. So in 2022, we had a lava flow start on the northeast rift zone here, and it took days to kind of reach this area where the land is kind of flatter, and then the lava flow slowed down, and it didn't cross the highway. This in orange is the highway here. So we were really fortunate in that it didn't really impact much. It did cross a weather observatory road, but yeah, just emphasizing that this is why we really emphasize to the public to be aware of Mauna Loa and the potential hazards. So here I wanted to mention that, we're island of Hawaii. We have some of the most active volcanoes on Earth, but on human time scales, it can be a little misleading. So I grew up with Kilauea in near constant eruption, and Mauna Loa was always this kind of looming giant that hadn't erupted in decades, nearly 40 years. So that can really impact your perception of the hazard. Now, Mauna Loa erupted in 2022, and here's an image of that eruption, or a video, so you can see the fountains high up on the East Rift Zone are feeding these narrow ribbons of lava flows that are traveling down slope toward that saddle area here between Mauna Loa and Mauna Kea, and this is where that road was, down here. So fortunately, the lava flows didn't make it to the road, but you can see that they're very destructive. Whatever they encounter is going to be destroyed. So I mentioned this kind of difference in that Mauna Loa over the past several decades hasn't been very active. And this plot here on the right is a lot to digest, but what I'm going to point out is that, so down here is 1780, the year 1780, and then going up is toward present day. All the dots here represent Mauna Loa eruptions, and the size is the volume of the eruption, the size of the dot. And 1950 is here. So you can see that prior to 1950, Mauna Loa was a lot more active. There were eruptions happening at the summit, at the rift zones, sometimes multiple eruptions in the span of a few years. Since 1950, there has not been as much activity, just a handful of eruptions, and we're missing the most recent eruption in 22 up here, 2022. But in 1868, that was very different. Our perception is really different now compared to 1868. So now Mauna Loa hasn't erupted very frequently, but then eruptions were really common. So this sketch here is a sketch of the 59 eruption, and you can see that there's a plume of gas, and then there's lava flow that's snaking down the mountain towards the ocean. So in 1868, a Mauna Loa eruption would not have been a surprise, really, to them. And before I start describing 1868, I just wanted to point out some of the sources of information. So in 1868, there were a number of local newspapers, both in Native Hawaiian and in English. So these are an amazing source of observations at the time. So I spent a lot of time looking through these. And then there's also letters from people experiencing things here on the island, journals. There are sparse photographs, not very many, and then some sketches and maps. And some of the key players that I'll quote quite a lot are Titus Cone, who is a missionary living in Hilo, Frederick Lyman, who is living out here in Ka'u, and then Reverend Paris, who is living in Kona. And then I also wanted to mention that Jim Kawahikawa, Janet Babb, and Ben Gaddis, Jane Takahashi, and Frank Truesdale at HBO have done a lot of work compiling all of this information and observations already. And so I drew from some of their work already for this presentation too. So thank you to them for doing a lot of the heavy lifting. So in 1868, what was life in Hawaii like? So Hawaii was still a monarchy, and King Kamehameha V was his reign at that time. At that time, there had been about a century of Western contact. So Hawaii was definitely in this mode of change. You know, just, let's see, over a decade prior to 1868, there was the Great Mahele, which changed how land was kind of distributed and owned locally. And then in 1850, there was a change that allowed foreigners to buy land. So there was an increase in Western, kind of a growing Western population here in Hawaii. And part of that was also related to the sugarcane plantations that were growing at that time, and the arrival of laborers to work at those sugarcane plantations. I did find a census from 1866, and at that time there were about 62,000 people living in the whole state of Hawaii, so less than the population of the island of Hawaii right now. And at that time it was still predominantly Native Hawaiians, so 58,000 Native Hawaiians and just 4,000 non-Native Hawaiians. And here on the island of Hawaii there were 20,000 people. Interestingly, when I was looking through the newspapers, tourism was definitely already a thing. So here's an advertisement for the Volcano House. They're, you know, calling for people to come visit the Volcano House, stay and see the eruption. And then here's a photo of the Volcano House in 1868 on the bottom here. And that's not the Volcano Arts Center right now is in a later version of the Volcano House, the one that was built in 1877, I think. So this is an earlier Volcano House. And then the photo on the right is of kind of the arrivals and departures at Honolulu. So at that time, travel between the islands was via steamship. So there were several different ones that ran through the islands, but news took a few days because you had to travel between the islands. Yeah, so now I'm going to just start walking through those events. We have a little bit of background, what life was like, that it took a little time for news to travel between these islands. And on March 27th in 1868, there was a very brief summit eruption. So this painting is not of that event. This painting is of likely of the 1880 Mauna Loa eruption, but I just wanted to give kind of an idea of what it might have looked like to people at the coast. So here you can see this is a view from Hilo, and the ocean is here, and then there's you know, the profile of Mauna Loa, and you can see that there's a plume up here of volcanic gas and maybe some fog being transported by the wind. So on March 27th, Reverend Paris, who was in Kona, he wrote, "We had a glorious sight from our veranda, a new eruption on Mauna Loa. About 20 minutes after 6 o'clock a.m., we discovered from the summit of the mountain an immense cloud of smoke. This continued to increase, extending south as it appeared to us. At night, we watched, expecting to see a great river of fire, but no, all was dark and still. When the stars came out, all was clear and bright as usual." So what do we have from this? We have a start time for the eruption, just about 20 minutes after 6 o'clock a.m., and we can also get from his observations that the eruption was over by nightfall because they didn't see a glow. Even though it was clear, the stars were out, they did not see a glow. And then Lyman, who was living here in Ka'u, he wrote, "An eruption broke out on Mauna Loa, a little to the southwest of the summit, about 6 o'clock last Friday morning, without any forewarning. About 7 o'clock, we began to hear a roaring sound, which grew louder and louder until the air seemed to tremble with the incessant roar of the volcano. But finally it subsided and ceased entirely about 8 o'clock. So he gives us an idea, even more so, of the time frame, that it was, let's see, about 6 o'clock and maybe over by even 8 o'clock. So very, very brief. And he also says that the eruption started without forewarning. So at this time, they were pretty astute observers, and they, you know, if they were feeling earthquakes, they were often kind of conjecturing that maybe there would be an eruption soon. But he's saying that maybe there wasn't a forewarning, so maybe there weren't any earthquakes before this eruption started. So the eruption was brief, and after it ended, there was a period of several days of very intense earthquakes. Here, felt in Ka'u, felt around the whole island, actually. And one of them was really intense enough to be felt as far away as Kauai. So let's see, Lyman, he was here in Ka'u. He says, "About noon, we began to feel slight earthquakes, and during the night they were frequent. Some of the time, every minute or two, though very slight, they were sufficient to prevent sleep. After sunrise, Saturday morning, the 28th, the shocks began to harden. They increased in violence until between 1 and 2 o'clock in the afternoon, when there occurred the hardest of all. with 3 shocks, which lasted about a minute. The swaying motion was so great that it was hard to stand up. The rest of the day, the shocks were not very severe. Saturday night, the shocks were very frequent and severe. The next morning, Sunday, a line of smoke had advanced about 15 miles since the morning towards Captain Brown's house in Kahuku. So during this time period, there were, we're learning near constant earthquakes. Some of them were so extreme, the shaking, that people couldn't stand up. And then Cone, who was in Hilo, he wrote, on the 27th of March, slight and repeated shocks of earthquakes were felt. On the 28th, these shocks became more frequent and more energetic, extending to Hilo, Kona, probably to all parts of the island. All of Ka'u was startled by heavy explosions and roarings, as of a tempest from the mountain. The mountain was rent apparently from near the summit crater, halfway down its southern slope, and jets of steam and smoke went up from many points. So these earthquakes caused a lot of damage. This photo you can see is of a church that fell. I think this one was in Waiuhinu. And actually, later on, we'll learn that nearly all the stone structures were destroyed during these earthquakes. But the interesting part of these observations is, the near continuous earthquakes, and then also the line of smoke that they observed down the mountain slope. So what was probably occurring now, we know, was an intrusion. So an intrusion is when magma is working its way beneath the surface, and as it does so, it has to break rock and make room. And so it was probably doing that, intruding in from the summit region into the southwest rift zone. And there were probably cracks forming and some steam being released, and that was that column of smoke and material that they were observing down the slope. And this kind of culminated in the largest earthquake that was ever recorded, or in recorded history here in Hawaii. There's no instrument recordings of this event, but the largest earthquake in Hawaii on April 2nd. So we've kind of pieced together from these reports that it was probably a magnitude 7.9. And Cone and Hilo wrote, at 4 p.m. on the 2nd of April, an event occurred which defies description. Such a convulsion has no parallel in the memory, the history, or the traditions of the Hawaiian Islands. The shock was awful. The crust of the earth rose and sunk like the sea in a storm. The shattering of buildings, crash of furniture, glass, and earthenware, the falling of walls and chimneys. Made throughout the southern half of Hawaii such scenes of terror as had never been witnessed before. So this was a really devastating eruption in Ka'u, earthquake in Ka'u. And one of we still use this earthquake metric today. It's called intensity, and it's based on how people are experiencing an earthquake, how they describe the shaking. And so what scientists have done is kind of gone through these observations and pieced together where the shaking was most intense. And that's how we get this kind of idea of where the epicenter of the earthquake was likely in this zone of the most intense shaking. But then extending out across the island, the shaking was still quite intense. And then it extended all the way to, actually the observations, people felt it even out on Kauai, so the farthest island, out there. But on Oahu, the shaking was intense enough to stop clocks. Now, we also know that likely what happened during this very large earthquake was that the entire south flank of the island moved. We don't really know how much, but we can kind of guess from the observations of the coast. And so these, the islands are built on the ocean floor, and there's a fault where this volcanic material, so lava flows, etc., are built on the Pacific plate. And that fault is probably what moved during this earthquake and moved out towards the southeast. And again, that was likely due to this, an intrusion of magma that was happening into the southwest rift zone. And these earthquakes today are still some of the most damaging here in Hawaii. So the earthquake in 2018 was a similar mechanism, but only on Kilauea. Part of the reason that this event was so damaging in 1868 was that it moved not only Mauna Loa's south flank, but Kilauea too. So the whole southern coastline probably moved several meters. And that movement had other kind of secondary hazards. So one was a very devastating mudslide in Wood Valley. And this is kind of an artist's sketch of it. And then this is a map that was made later by Kohn when he visited several months later. And they write about this mudslide that the eruption came down on both sides, leaving only one house where the school teacher was and a few people who were in it. It completely surrounded them. But they afterward crawled out over the bank of the earth and came to see us. The earth eruption swallowed up 30 persons. The next day after the eruption, on looking carefully, we saw that there had been small movements of earth along the edge of the woods. And then Kohn, he visited later and he wrote, huge rocks, trees, fences are intermingled as if the top of the hill had been blasted off in a great mass. Our native guide who was present at the time of this assured us that the flow ran down like water and that it was not caused, as some have supposed, by the cracking open of ground. There was every appearance of a genuine flow. Near the center, a little island is left upon which stands a house. The actual depth of the mud is difficult to determine. It perhaps ranges from 5 to 30 feet. 31 natives were buried alive on that event, and about 1,000 head of cattle. So when Kohn visited it several months later, he estimated that it was about 3 square miles in size, which is equivalent to nearly 2,000 acres. So this is a really big mudslide. And if we assume that it had an average depth of about 15 feet, the volume would be equivalent to 9 Olympic swimming-sized pools. So this was, yeah, really devastating. And then not the only, it killed 31 people, but across the islands there were landslides and rockfalls that killed several other people as well. So that movement of the whole south flank of the island also caused a tsunami that was devastating as well. And here are some observations of the tsunami. At about 5 o'clock, the sea was observed to recede, and the space between the reef and the beach was left dry in many places. The sea ebbed and flowed 13 times, and the time between each flow was between 7 and 8 minutes. In Hilo, the sea came in yesterday, 2nd of April, and washed up to and over the Waiakea Bridge, up to the King's Fish Ponds, carrying away all the walls in several places. At Punalu'u, 3 deaths from the scene. The village of Waiuhinu is all in ruins, and about 20 lives are reported as lost. The sea came in at Keoho and Apua and carried away all the houses. At Keoho, the natives escaped by running. It is feared that the natives at Apua were not so fortunate. And then several other reported deaths along the coast. So yeah, at the same time as the mud flow, over the subsequent hours, also a tsunami, which was really devastating. And then several days later, an eruption occurred here on the southwest rift zone. So here, let's see. On Tuesday afternoon, April 7th at 5 o'clock, a new crater several miles lower down and about 2 miles directly behind Captain Brown's residence burst out with a heavy roar and frightful crash. The lava stream commenced flowing rapidly down the beautiful plateau towards the farmhouse, and the inmates had barely time to escape with what clothes they had on before the houses were all surrounded and enclosed with streams of fiery a'a lava, varying from 5 to 30 feet in depth. So here's a view, a modern day view from just if you drive to the end and then look back towards Ka'u, to the highway area. There's this pali here that is, I think, informally called Kahuku Pali. It has a couple of other Hawaiian names, native Hawaiian names. But if you have that vantage point, you can see where the 1868 lava flow came down and skirted the very edge of that pali. And I'll show a map of that later. But here's a drawing from 1868 of that same vantage point. And you can see this several lava fountain features that fed lava flows that traveled downslope and skirted the edge of that pali. So at the time, they were estimating that the fountain heights were up to 500 feet high. So Captain Brown, the eruption started just above his property, as we just heard, and then they wrote about this event as well. On Tuesday the 7th, about 5 p.m., the family of Captain Brown were startled by an explosion and a terrific roar about 2 miles from their house. At once, they saw several jets of lava mounting upward nearly 1,000 feet, while smoke and steam shot up to the clouds. The glare of the fire caused a lurid light far and near, while the lava was seen coming down rapidly upon their doomed dwelling. The family and the natives about the premise ran for their lives, first in a wrong direction, happily soon corrected by Mr. Swain, whose presence of mind pointed out that up the mountain and across the gulch was the only chance of escape. Panting and excited, the people gained the farther bank, when in a few minutes the glowing lava poured through the gulch, filling it in with a stream of living fire. The stream parted at the source to join again further down. On an enclosed space of grassy land, more than 200 head of cattle were feeding. So here they're describing how the lava flow branched and then came back together, and there were 200 cattle that were trapped and eventually covered with lava. So today out on the highway, there's actually a monument to Captain Brown's lost residence that you can still visit today. And then there was, I guess he had lost a daughter before the eruption. She didn't die in the eruption, but after the lava flow covered his property, he located her grave site and was able to move her body somewhere else. So here are some maps of the eruption that Kohn made when he visited the eruption site months later, and you can see, I mean, for the times, I think he did a fairly good job. So here's the actual modern map of the lava flow, and then here's that mud flow that we talked about here in Wood Valley in Pahala. So the eruption was pretty brief. It only lasted 5 days long. Some Mauna Loa eruptions can last over a year. The lava flows were 10 miles long. They traveled 10 miles from the source vents, which are just here in the park, and you can visit them. They reached the ocean in just a few hours, and they covered about 5,000 acres. And at the coast, there was a littoral cone built up where I think it's the next slide, where the lava entered the ocean. Here's another interesting photo of a family that was actually trapped in the lava flow, branched and then came back together, and then that's called a kipuka, and they were trapped there for, they say, I think, about a week before they could be rescued. And so here are some aerial shots of the lava flow. So we talked about it, starting and then skirting the edge of the pali, so you can see it come down here in dark black. And then this is also a different branch of that same lava flow. Here's the cone that it built when it entered the ocean, and this is called pu'uho, which means, I think it means new cone. And then the other really interesting thing about this eruption is that the lava is called a pickrite. You can go hike just near here on top of this lava flow, and you'll notice that it has quite a lot of olivine. And the thinking is that the vents, let me go back to this map, the vents for this eruption were at a relatively low elevation on the southwest rift zone. So here's the vent location, and the summit is up here. And if you were to take a three-dimensional cutout of the volcano, the magma chamber is below the summit. But this eruption happened at a relatively low elevation, and it erupted a pickrite, they think, because it tapped into magma in the magma chamber that is, the magma chamber is compositionally zoned, meaning that the way I think about it actually is like a chocolate chip cookie. You mix everything together and you've got the chunks of chocolate, but as you bake it, those chunks of chocolate might melt and mix in with the rest of the cookie. In a magma chamber, the magma is really hot, everything's mixed in together, but as it cools, you might get crystals forming in that magma. And those crystals are going to be heavy and dense and sink to the bottom. And so that's what this likely represents, is kind of the bottom of that magma chamber where the olivine crystals have kind of settled out. And so because this eruption happened at a relatively low elevation, it probably tapped into that lower part of the magma chamber. So these slides are from Drew Downs, and if you went to his talk, he had an After Dark in the Park presentation on Tuesday about Kilauea's southwest rift zone, and he mentioned that in 1868, Kilauea also erupted. So there was, if you can imagine the whole south flank of the island moving, Kilauea is going to be impacted too by those changes in pressure and movement. So there was in 1868, a small eruption in the Kilauea Iki crater. And today there's no evidence of that eruption because it's covered with lava that erupted in 1959. And then there was also a small, really tiny eruption on the southwest rift zone of Kilauea that happened, I think, the same day as the large earthquake. And so that's here. this tiny little pads of lava here that erupted at Kilauea. So in terms of impacts, the 1868 event was really devastating. At least 100 houses were destroyed and many more were damaged. The roads in Ka'u were cracked and displaced by several feet. Even roads in Hilo were cracked and displaced by up to a foot. At least 1,300 cattle were killed. And then in 1868 dollars, the damage was 70,000. If you translate that to today, it's about $1.5 million in damage. The number of fatalities is hard to estimate, but low estimates maybe in the 70s, high estimates in the 80s. At least 30 people were killed by that mud flow, and then several by the tsunami and other rock falls around the island. There was also fog reported in Honolulu for the days of the eruption. So let's see, they wrote, the smoke, and this is from Honolulu, the smoke of the volcano which hung about Honolulu for 3 or 4 days, being observed the first on Friday the 10th, was also seen by Captain Stone on the Brigham Kamehameha V at sea. So they're talking about fog being observed also at sea, 400 miles west of Honolulu. The sun on Friday with him, as with us, rose shorn of its accustomed brightness and could be looked at comfortably with the named eye. So you could look at the sun because there was so much fog. And for those of you, sorry, fog is volcanic air pollution, for those of you that aren't from here. And for 4 days, the whole atmosphere was thick with smoke. And then they wrote of Ka'u, the land all through Waiuhinu is badly fissured and moved. In one place on the road to the landing of Ka'alualu, the action is distinctly marked by fissure, on one side of which the road is displaced several feet. Not less than 100 houses throughout the Ka'u district have been completely destroyed, while numerous others have been more or less injured. And in 1868, Kamehameha V, he did launch a relief effort. You know, it took several days for news of all this devastation to reach him in Honolulu. And then by April 18th, the local newspapers were kind of reporting that he was proposing an aid trip. And then, oops, I may have those switched, sorry. April 15th, the newspaper reports, and then April 18th, his relief effort was arriving in Hilo. And they delivered aid to about 800 people, food, lumber, and clothes. And they wrote, the newspapers kind of wrote of his relief effort. On his arrival at Hilo, he sent messengers through the district notifying the people of his arrival. At Hilo, he met the destitute on the 17th and spent 8 hours distributing clothing to 110 persons. At Keauhou, relief was given to 68 men, women, and children. At Punalu'u, clothing and lumber were distributed to 364. At Ka'alualu, the greatest destitution prevailed, and some were really famishing. Here, food, clothing, and lumber were distributed to 257, in all about 800 persons. So the other interesting thing I noticed was that the earlier newspapers were kind of advertising tickets for tourists to go and look at the eruption on the steamship Kilauea. And they were being advertised at $40, which would be equivalent to just under $1,000 by today's numbers. But that in subsequent newspapers, they report that trip postponed because Kamehameha V, he used the Kilauea steamer to go deliver that aid. So in hindsight, there was likely also what happened, a partial summit collapse at Kilauea, or at Mauna Loa. So for those of you who are here in 2018, we're very familiar with this sequence of events that happened at Kilauea, where there was a flank eruption relatively low on the volcano, and then at the summit, there was the summit partially collapsed because so much magma from that summit magma chamber was erupted lower on the flank of the volcano that the roof of the magma reservoir is unsupported, so it collapses down. And that likely also happened in 1868 on Mauna Loa. So this map on the left was done by Wilkes in 1840, or 1841, yeah. And you can see that there's this kind of odd-shaped partial crater, maybe some eruptions filled in over here. And then, yeah, the main caldera is kind of extending over here, and a little pit crater. In September 1872, there were observations, the people weren't visiting the summit very frequently, so we have to kind of piece it together based on these sparse records. But in 1872, some folks visited the summit caldera and noted that you can see this area is much larger, and it's actually circular now. And then the caldera itself was likely a little bit wider. And they also noted in the center that there was a pit. So, the quotes, 1/3 of the floor of the crater is much lower than the rest, and it has evidently subsided since Wilkes's visit. The depressed portion may be 200 or 300 feet below the other. And Thomas Jagger, who founded the Hawaiian Volcano Observatory, he kind of put this together too. And he said that there was another survey about 33 years after Wilkes. So Wilkes was in 1841, and then there was another survey 33 years later. Lightgate's survey 33 years after Wilkes notes higher western and eastern walls of the caldera and a larger and deeper southern pit. The northern embayment had become an elliptical pit, and the lunate platforms had sunk deeper and changed proportions. A new southwest extension of the main crater floor contained active lava in 1874, and it was the scene of lava fountains for years after 1872. So yeah, it's really interesting to look back at these events now that we've experienced 2018 in the modern kind of monitoring realm and seen what a summit collapse can look like. And Frank Truesdale has done some work digitizing these maps that Jagger made based on those observations. And his estimate is that the collapse of Mauna Loa in 1868 may have been bigger than that of Kilauea in 2018, which is just, yeah, amazing to think about, because Kilauea in 2018 was so large. So this photo on the left, for those of you who weren't here in 2018, this is Kilauea's summit before it collapsed in 2018, and then this is after it collapsed. And again, the parallels between 1868 and 2018 are really interesting in that both of them had these lower elevation eruptions and large earthquakes and big flank movements. And so the idea that maybe Mauna Loa had a summit collapse, partial summit collapse too, is not, yeah, it makes sense. The other interesting thing is that now, in the period after 2018, we've been, at Kilauea, been having mostly summit eruptions following that big collapse. And the same thing happened at Mauna Loa after the 1868 eruption. So for the next 10 plus years, there were only summit eruptions. So one in 1871, and then from 1872 to 1877, there was kind of nearly continuous summit eruptive activity. 1877, 1879, 1880. So it wasn't until 1881 that the first eruption outside of Mauna Loa's summit caldera happened. And so here are just some illustrations of what that summit activity looked like. And so there was one specific area that there were lava fountains were often noted, and some of these were pretty visible even from Hilo. And so a sketch of that area too here. So yeah, in retrospect, there's so much information in these really detailed written accounts from 1868, and there's so many rabbit holes that you could go down, and I tried to limit it, but there's still, I think, a lot that we could learn from this event, and we don't really understand the frequency of these large earthquakes, but the fact that we have these detailed records at least gives us an idea of what occurred in 1868, and the fact that this could potentially happen again at some point in the future. And the island population has grown quite a lot, so it just stresses to us the need to make sure people are aware that these types of events are possible, and to mentally prepare your homes. We always stress having some kind of evacuation kit, and that's good in Hawaii even for all hazards preparedness, not just for eruptions and earthquakes. So just to touch on monitoring, this is a snapshot of our monitoring network, and today we monitor the volcanoes using a slew of instruments. I've listed, I think, kind of the general categories here. So kind of the backbone of the observatory and the kind of monitoring program is our seismic stations, and then also ground deformation. So seismicity, that's going to tell you about earthquake locations, and then magnitudes, and then also the ground deformation is, GPS and then ground tilt, which can give you an idea of how the ground motion is moving related to whether magma might be coming into an area or moving out of an area. We also have webcams, a really extensive webcam network, and after the eruption a couple of years ago, we're kind of looking at expanding the webcam coverage here in the Southwest Rift Zone. So it's tough because of the steep slopes to get good views, but we're working on it. And then just in the past couple of years, we've put a camera on Hualalai that looks towards Mauna Loa. So that's really useful. And it's actually it's called a pan tilt zoom camera, so you can control the view angle and the zoom. So we also have, volcanic gas monitors, a number of other things, but yeah, pretty good coverage. And then wanted to note that a lot of this monitoring data is available on our website. So if you're curious, you can go look at it yourself. And on our website homepage, there's a monitoring map. On the right-hand side, there's a bunch of filters that allow you to select if you wanted to look at earthquakes of different sizes or over different time frames. I don't have it pictured here, but there's a similar filter that says instruments, and you can turn on and off the different, if you wanted to look at the webcams, you could see where they're located across the landscape, or if you wanted to look at the GPS, you could select those. And then you can also click on the individual instruments to look at the data. So a lot of this is available, and we encourage you to look at it, and also to let us know if you have questions. So that's all I had. I certainly learned a lot looking through all this documentation, and I hope that you learned a little bit today, and I'm happy to answer any questions.
Yes, I have one. To my knowledge, the lava zone maps, which we use for real estate and insurance purposes, haven't been updated in about 60 years. Are they in the process of any significant changes or updating?
So the map is, oh yeah, yep, yeah. So she asked about, we have here in Hawaii a lava flow hazard zone map, which outlines the areas that are susceptible to lava flow hazards. And the regions on the rift zones are high hazard. Those are the most hazardous, and the summit. And then downslope, it's decreasing hazard, and then also related to how frequently certain areas erupt. The map is from '92, so it's not been 60 years, but it's been, nearly or over 30 now. I think we are in the process of updating it, but there's not going to be any huge changes, and that's in part because the map is based on the geologic history of the volcano, and that hasn't really changed. The history remains the same. We might have, some fine-tuning changes based on, better dates of lava flows and things like that. But essentially, the main message, which is that the highest hazard areas are at the summits and the rift zones, stays the same. Yeah.
So Ocean View and Rancho's area, there's still going to be lava zone 2 for a gazillion years.
Yeah. Yeah, and I mean, like
we have an eruption out here, that'll be lava zone 1 again.
Well, yeah, and I mean, like I showed, it's very interesting because Mauna Loa, after 1950, hasn't had very many eruptions. But you look at the period prior to 1950, and it was really frequently active. And sorry, if I go back all the way to the beginning of the talk, these colored lava flows are only since the past couple hundred years. So you can see that there were big areas of the Southwest Rift Zone that erupted and sent lava flows down to the ocean. And we're kind of right now in this period of not knowing. Mauna Loa now erupted in 2022. It had been 38 years since the last eruption. Are we going to enter another phase of Mauna Loa erupting more frequently? Or is it going to be another decades between eruptions? And right now we're not seeing any sign of activity at Mauna Loa. It's still quiet after the 2022 eruption. But long term, in the geologic history, going back centuries, that these patterns aren't going to change. So yeah. Mm-hmm.
And Hualalai is still a possibility of eruption.
Yeah. The question is whether Hualalai could erupt in the future, and Hualalai is still, it last erupted in 1801. It's still an active volcano, and we know that in 1929 there was a really intense earthquake swarm on that volcano that likely represented magma moving up into the volcano, but not making it to the surface to erupt. So yeah, 1929 is not that long ago, just almost 100 years, but Mauna Loa or Hualalai also, we're not seeing any signs of activity. So, we would anticipate if there were going to be some activity at Mauna Loa, we would see earthquakes, ground deformation in the lead up to that, and we're not seeing any of that. So, yeah. Oh, I think you were first.
I guess what my understanding was initially that Mauna Loa started to come down southwest. What causes that to change and go the other direction?
Are you asking about in 2022?
Yes.
Yeah. So it sent lava flows. Let's see, are they on here? Yeah, they're these red ones in here. So you can see they didn't make it very far down. There's a really nice Volcano Watch article on that from last week. So we write a weekly article that you can subscribe to, and it talks about how we have this, the modern extent of the caldera that we can see visually as, there's, a depression in the ground. But if you look, there's actually cracks. There's kind of an outer caldera region. And so these lava flows that kind of went down, they look like they're extending into the southwest rift zone, but not really actually. They were still in this extent of the summit region that is often active in the summit phase. So, at the beginning of an eruption, often for Mauna Loa, always the summit erupts first, and then it may or may not move into a rift zone. But when we say the summit erupts first, we mean that summit region, which encompasses also this area that looks like it's out of the caldera, but it's still part of this summit region. So yeah, it didn't actually propagate into the southwest rift zone. Yeah. And actually, if you look at historical records, and the Volcano Watch talks about this, that happens a lot. There are often views of Mauna Loa during summit eruptions where folks could see, those lava flows extending down this flank, but not representing a southwest rift zone eruption. So, yeah.
While you got it up there, the map, Mauna Loa, the eruption on the northwest side, it seems to be an anomalous flow that went out around, I'm going to say 11,000 feet.
That one, yeah.
Over 30 miles into the ocean north of Kiholo, I think.
Yep, yeah.
Why the anomaly when everything else is confined to the northeast or southwest rift zone?
Yeah.
And that was from the 1800s, I think. What
Mm-hmm.
do the geologists up there have a reason for why that happened?
Yep, yeah. So the question is about this lava flow here, which looks like it's out of a rift zone. And I talked about how those are where rift zones are where eruptions happen. So why is that one out of a rift zone? And that's a really good question. So Mauna Loa is unique, and I didn't mention this, I should have, in that it has these features called radial vents, and that's a radial vent. So the way someone described it to me, and I think this is a really good description, is that the Pacific plate is moving to the northwest. Mauna Loa is this massive volcano riding on the Pacific plate. And so as the whole island is moving to the northwest, there's going to be, if you can picture like a 2x4 that you're trying to bend, there's going to be kind of like spaces that open up, maybe even cracks that open up on the opposite side of the 2x4 as you're bending it. And so the idea is that these radial vents form on Mauna Loa because of that kind of opening that is accommodated by that motion of the Pacific plate. So the radial vents only occur on this area of the volcano, the northwest flank pretty much, but they can occur anywhere. You'd have to ask Frank Truesdell, but there's I think dozens of them that he's mapped all over. And then the 1877 I think eruption of Mauna Loa happened in Kealakekua Bay, and that was a submarine radial vent eruption. So it happened beneath the ocean surface, and there was, accounts of pumice floating on the surface and dead fish. So yeah, these are unique features. I think that was 1877, if I remember right. Yeah, and this one it happened in 1852 or 1859. Yeah, I'd have to look.
Do you know the distance off the top of your head from where it erupted at the radial vent going into the ocean?
Oh gosh, that's a. Yeah, yeah, it's definitely over 30 miles. I know that it took 8 days to do that distance. I don't know the distance off the top of my head, but yeah, and 8 days, that's relatively quick. Whereas Mauna Loa here, this eruption in 1880 that went from the northeast rift zone towards Hilo, that one took months to get into Hilo, so yeah. Yep.
If you go out to the coastline where that flow goes in, and you look back towards the mountain, this amount of cinder cones on that hillside, I don't think very many people really sit to consider what they're looking at. All the venting that's happening in that entire area is pretty awe-inspiring.
Are you talking about at the coast? He's mentioned that if you go to the coast and look up the slopes of Mauna Loa, you can see many cinder cones. The coast down here or the coast in Kiholo?
The coast from Kiholo looking up towards the top of the mountain, there's 30, 40 cinder cones.
Yeah, well those, I think some of those you might be thinking of Mauna Kea cones, which are different. Yeah, yeah. So yes, but yeah, definitely.
The venting there is all I was trying
Yeah.
to focus on.
Yeah.
We went on a tour up in the water, and looking back, it was very impressive to see this is all moving. This is all alive.
Yeah, I mean, it's interesting living here in Hawaii because we get to see geology in action, you know, land created, land destroyed, and I think that's really special, but it's also, you know, you really learn to respect that too and live with it, but also it can be so destructive and beautiful at the same time, and it's and powerful. So, yeah. Yes.
Yeah, for the park map, can you walk right to the lava where it began?
For the 1868 eruption? Yeah, you'd have to talk to the rangers to get the best idea, but it's not too far from here, right?
Right along the road.
Yeah.
That's several.
Yeah, the fissure vents, yeah. So, and if you decide to do that later today,
It might not be clearly marked, but when you walk down into the lava flow, you also, the 68 lava flow, you also see one of the fissures that open up.
yeah,
That is marked.
okay, yeah, so,
Are you doing anything on the 1877 and the 1907? Because that information is still vague now that it's part of the park.
you know, I'll write that down and maybe we can, you know, try to do some Volcano Watch articles on it, or I can look and see if we have some Volcano Watch articles.
Those two really aren't in the history yet.
1877 and 1907?
Right, but now that you've got the lower Kahuku part, that might be of interest to go and build that up and include it now.
Yeah. Yeah, we can definitely,
Yeah, you haven't seen much on those two flows, have you?
well, they're definitely, you know, there's geologic mapping, and I'm sure we have some resources, but
Nothing written up like the 1868.
yeah, I don't think so. Yeah. Yes.
Up higher, there's a pitch creek.
Mm-hmm.
So how does that fit into this? Did that happen at the same time or at a different time? Or how do they put that in perspective with all of this activity?
Okay, so the question is about a pit crater up above here and how that fits into the story. I don't know off the top of my head, to be honest. I could look at a geologic map or talk with Frank Truesdale, who's really familiar with the geology of Mauna Loa. But pit craters, they form when there's, you know, magma moving out of an area and leaving some kind of a void that then causes the crater to collapse. And so it's just like in Hawaii Volcanoes National Park, there's Chain of Craters Road, and that's kind of parallels the rift zone in some areas. And so we know that rift zones are where eruptions frequently occur. So there's magma moving beneath the surface pretty frequently to feed those eruptions. And then as the eruptions occur, they might leave voids beneath the surface, and that's what forms those craters. And so here we're on the southwest rift zone of Mauna Loa. So it's the same processes where magma moves into an area and then maybe moves out of that area, and then you might get these collapsed pit craters. So I don't know if that one directly relates to 1868 or not.
Are there other pit craters in this park?
I'm sure, yeah, there are. I think there's like one really beautiful forested one pretty high up, right?
That's the one you can get to.
Okay. Yeah.
These are really not open to the public.
Okay, yeah.
They will be in the future.
Okay, Yes.
We are having an April coffee talk on the pit crater. We are having an April coffee talk on the pit crater.
Okay.
So if you want to know what's going on in the park, put your name on the email list, and I'll send you a monthly alert about what's happening. But it'll be about the foliage and all the plants that are growing in it, as well as how it formed. And the guy that's going to do it is actually one of the people who rappelled into the pit crater when we first acquired the park. So it should be a wonderful coffee talk.
And then if you haven't done the Chain of Critters drive, definitely recommend that. Yeah. Yes.
Two questions. First one, I know during the 2022 eruption, there was problems with some of the GPS monitoring stuff on the summit, and I'm wondering if there's being funds allocated to put in more GPS monitoring and to repair whatever's up there. And the second question is, you guys talk at all with the folks in Iceland?
Oh, okay. Yeah, so the question was about GPS and whether we're putting in additional GPS, and then the second question was about whether we talk to people in Iceland. Regarding GPS, I am not aware of any issues in 2022. There were maybe some telemetry issues at the start of that eruption, so that's not an issue.
Yeah, that's what the folks with HVERI, not Dane, but
Phil?
he was, he does this thing every week, and they were reporting that they were having problems with the GPS monitoring. They've lost one of the stations. I guess there's 4 of them up
There's
around
several,
the summit.
yeah.
They lost one, and it was another one was intermittent, I believe, at the time.
Yeah, it sounds like there's maybe telemetry issues. So that's like, we have these instruments out on the landscape, and they're solar powered, and then they transmit data, but sometimes there can be issues in that transmission. And so it's not really an issue with the station itself, but it might be a telemetry issue, and those are usually resolved pretty quickly. And I know there were some the night of that eruption, but
Get the Marines on it.
to my knowledge, everything's functional right now.
Okay.
So yeah. And we did, after the 2018 eruption of Kilauea, and there was so much instruments and the buildings that were damaged, we were allocated supplemental funds to bolster our monitoring network. And so those funds are what are paying for like the webcam that I mentioned on Hualalai that looks at Mauna Loa. And so the network has grown quite a bit since 2018. Yeah. I'm not sure about that, but.
Yeah, you did.
And then regarding Iceland, we, I guess I'm not sure if your question, you mean like in regards to monitoring or?
Well, do you guys talk?
Yeah.
Because I see a lot of similarities with what goes on in Iceland. I know
Yeah.
it's different, it's not a hot spot, but, the lava is very, typical. It's pahoehoe as opposed to
Yeah, we have, at meetings, representatives from observatories go from around the world to various meetings and, talk about, the meetings have different themes, whether it's science or operationally how an observatory is functioning. So at these meetings, there's a lot of sharing of information and like developing best practices for volcano observatories. So
I would think that, once a week or once a month, half hour, 45-minute talk with whoever's in charge in Iceland. You guys get on Zoom.
Yeah, I think that's a great idea, and it's wonderful to learn how other observatories are doing things, and then have them learn from us.
Hey, they're doing this, and why aren't we? Or vice versa.
Yeah. Yes.
Is there any correlation between like Kilauea lava flow and Mauna Loa as far as them affecting each other?
Yeah, the question is whether there's a correlation between Mauna Loa and Kilauea and lava flows and how they affect each other. And there's maybe, if you look at the historical record over the past couple hundred years, there's maybe a suggestion that when Mauna Loa is more active, Kilauea is less active, and vice versa. So when Kilauea is in eruption, Mauna Loa is less likely. So it is really interesting that Mauna Loa has been pretty quiet over the past several decades, whereas Kilauea has been erupting nearly continuously over the past several decades. But there's also instances where they're both simultaneously erupting. So that happened in 2022, and then they both kind of ended around the same time in 2022. So I think we're still learning about how they interact, and they're both, yeah, they do influence each other. So when Mauna Loa erupted in 2022, the volcano showed signs of deflation because, you know, a bunch of lava had been erupted on the surface, and that deflation signal kind of also transmitted to Kilauea. So Kilauea was also showing signs of some, you know, movement back towards Mauna Loa because Mauna Loa had deflated. So they can definitely influence each other, but I think we're still learning how that is, because Mauna Loa, the 2022 eruption was the first one that's been really monitored with a lot of our modern equipment. So it was the first opportunity to see a lot of that in action. Yes. Oh, sure.
Loihi, or whatever it's called nowadays, does that fit in with the other two, and are you monitoring it too?
Yeah. So Loihi is a submarine seamount. The question's about Loihi and how it fits into our observatory and monitoring. And yeah, Loihi was renamed Kamaʻehua Loa. And we don't have any instruments on it because it's under the ocean, but we do monitor it as we can using our land-based instruments. So there's a bunch of several seismometers or earthquake detecting devices in kind of the region of Pahala.
Interaction or change in this when Kilauea goes off and Mauna Loa goes off?
Is there any interaction with Loihi when Mauna Loa or Kilauea? I don't think so. Loihi, yeah, we saw some activity at it a few years ago, some earthquake activity, so maybe something was going on. But before that, the last eruption was 1996, for sure. So yeah, we don't really see too much there right now. Yeah.
I was just wondering about the connections of the hotspot.
Yeah, I'm sure that it does kind of impact because it's all coming, they're all being fed by the same source. So yeah. Yes.
Yeah, during the initial phase of the 2022 eruption, in what direction was the lava flowing?
The initial phase, so the question is where the lava flowed in 2022.
And the second part of that question is, where would it have ended up on the coastline?
Okay, yeah, and where would it have ended up on the coastline? So it's in darkest red here is the 2022 eruption, and see these fingers here of flows. Those were where the initial flows were happening just the first night of the eruption. I think that, so they've actually done some modeling looking at, you know, they can model the slope of the volcano, and we do that, yeah, when new eruptions start to get an idea of where the lava flows might go. And I assume it would have just gone, I can't remember off the top of my head, but you can see it's like following this kind of blue lava flow here, so headed towards the coast there. But that eruption, you know, the summit phase ended within a day, less than a day. By the eruption started during the evening, and then by the next morning, the summit was done erupting, and the eruption had moved here to the northeast rift zone, and then the lava flows traveled this direction, so north, pretty much due north towards the saddle.
Do you have any idea what community would have affected on the coastline?
Well, I mean, South Kona, so, you know, not quite Kealakekua area. Yeah, but so that area, yeah. Fortunately, it stopped though, so.
The two narrow, thin, in red lava flows that reached the coast in 1950, that's Kona Paradise, so it would have to be north of Kona Paradise.
Mm-hmm.
It wouldn't be Nolalihi. And it would be whatever lies north of Kona Paradise. So
Yeah, I think but Kealakekua's, yeah.
Kealakekua is a big
So, yeah, and one of the tools that Frank Truesdale, who's kind of he is the Mauna Loa expert, that he put together is these lava inundation zones. So it's a series of maps that separate the flanks of Mauna Loa into zones, and so it basically tells you, hey, if there's an eruption here on this spot in the rift zone, it gives you a zone where lava flows could go to the coast. So if you live out here, definitely recommend taking a look at that, because that's the tool that Civil Defense uses as well. So they, in 2022, they had maps with those layers. And the idea was like, if an eruption starts on the Southwest Rift Zone, they could easily say, okay, well, the lava flows could go into these 2 inundation zones, so these are the ones we need to focus on evacuating. Yeah.
What was the name of that map again?
It's the lava inundation zone map. Yeah, and so if you want any of these resources, you can email AskHVO, and I'm happy to email you the link too.
Thank you.
Yeah. Mm-hmm. Yes.
I just have an observation. We're in Ranchos, and our front door opens to the north. And prior to the 2022 eruption, I could frequently smell sulfur in the breeze coming down from the northeast, which we later learned there are vents through Ocean View up in Hove.
Yep.
Yay, I haven't smelled any ever since the 2022 flow, and we're still getting the same breezes. So could that mean that the lava is not so close to the surface?
So the question and observations were that you could smell sulfur in the lead up to the Mauna Loa 2022 eruption, but you haven't smelled any recently. So I guess to address the first part of that, we do have instruments that measure volcanic gas above Ocean View, and they didn't detect anything prior to the 2022 eruption. So the smells, that's interesting you smelled those. I don't know if maybe they could have been, we also have instruments at the summit of Mauna Loa too, and we didn't see any increase prior to the 2022 eruption. I'm wondering if maybe you could have smelled some, Kilauea was erupting at that time, so maybe the breeze was bringing some of that. Or sometimes people write us, and when plant matter is decomposing, it has a smell that can be sulfury. And so oftentimes people email us and worry that there's something happening on their property, and we find that it's related to decomposition, not to volcanic activity. So yeah, so that's an interesting observation. I'm not sure if what you smelled was volcanic or not, but regarding like whether or not that the fact that you haven't smelled that, and maybe it indicates that magma's not moving into Mauna Loa again, I would say that, at least based on our monitoring, there's no indication of Mauna Loa. Yeah, we're not seeing signs of activity right now. It's really quiet, so yeah. Yes, yeah, definitely. Thanks, everyone. Thank you for coming out, and yeah, please feel free to email AskHVO if you have any follow-up questions. We check that every day, so.
Thank you very much.
Yeah.